Right, in this example, there are three parts to it. We'll take a look at how we can learn some new techniques where we have permutations with some restrictions. So, how many ways can the letters of the word altruism? First thing we note is actually all the letters in the word are different. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 different letters. And how do we arrange it such that all three vowels are together? We've learned it before. The technique here is really to group the three vowels together as a unit, as a group, and then arrange them as 1, 2, 3, 4, 5, 6. 6 units here like that. So therefore, number of ways must be 6 factorial because you cannot arrange 6 groups, right? Times 3 factorial because the A, U, I is not just in this order, it can be in U, A, I, A, U, etc. etc. How many ways can you arrange 3 units? Then it must be multiplied by 3 factorial. Multiply because you are doing it in succession. So therefore it's 4320. That's out of the way, a bit of revision. Let's take a look at the second part B, second part, where the first and the last letters are consonants. So if you take a look, there are actually 3 vowels and 5 consonants. So let's settle the first and last place, right? They must be consonant. One way of thinking about it is the first slot, there are 5 different choices. It can maybe a T, L, M, doesn't matter, the T there is for illustration. And then this last letter can be 4 choices. After you struck out the T, there are 4 different ways. Alright. So that, and then you subsequently arrange 6 others, because once you have T or M is in, it could be T, it could be M, it could be others, then you will multiply by 6 factorial. So this 5P2 is equivalent to 5 times 4. Now, to make it less confusing to all of us, you will use 5P2. It's easier. Of course, you can take 5 times 4. That's not a problem as well. Multiply by 6 factorial because that is done in succession. Therefore, it's 14400. The final part is the most confusing part where you want all 3 vowels to be separated. Alright, again, you have 3 vowels, you want it to be separated. Now, a common misconception, a common mistake that people do is you take, since you want all 3 to be separated, can I take the total number of ways, which is no restriction, right? Which is essentially just 8 factorial, right? Minus away your answer in part A. Just recall, answer in part A is when all 3 vowels are together. So, the answer is no. Why? Simple. Consider this arrangement, right? If you take the total number minus, if you take the total number of ways you rearrange minus all 3 vowels are together, you will actually get the complement. The complement is actually when all 3 are not all together. I say again, 3 are not all together. So, let's take a look at this example. This is where U, I, A are not all together and they are separated. But there are actually some cases where the vowels are not together, but not all are separated. So, if you take this, you actually will count this case in. But what you want is actually when all 3 are separated, really separated. It means it's not 2 plus 1. So therefore, there are cases that they are not, the 3 are not together, but not all are separated. So if you take a look here, this A and the I are together. So if you just do this case, the right hand side, you will just find the number of ways where not all 3 are together. Basically, not all 3 are together. So this is not the way to do it. Then how do we do it? So the idea is what we call an insertion method. This is a very useful method when you want to separate items. Let me illustrate. First, we will arrange, right, the objects that are in this case, since you want to separate the vowels, you arrange the other objects first. That means you arrange the consonants first. I say one more time, since you want to separate the vowels here, you don't arrange the vowels first. You arrange the other items first. That means the 5 consonants first. Then, the number of ways to arrange the 5 must be 5 factorial. Then, after that, we create the slots in between the 5 consonants. If you count the number of slots here, it is 1, 2, 3, 4, 5, 6. There are 6 slots that I can slot. I need to slot in the A, I, and the U. So, A can be here, U can be here, this is an example, and I can be somewhere there. Doesn't really matter. As long as A, U, I fit in any of the 6 slots, my job is done. So, therefore, the number of ways must be 6 slots. Permute 3. Right? So, therefore, I get 1, 4, 4, 0, 0. I hope this insertion method you can use it, you will use it, and this is a very classic example of how we use the insertion method. Thank you.